Okay, so here will be a video explanation of this first question you guys did. If you were good with it and you understood everything, then feel free to not listen to it, okay? But if you did have some questions and were confused on some of it, then it'd be a good idea to listen to this. So this is a graphing calculator. Again, you guys will have them for your whole test anyways. You're given a table, and it says a tank has a height of 10 feet. The area of the horizontal cross section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Select values for a of h are given in the table above. Okay, so what we do know if we were to just even look at a sketch, so just something to think about. Here, this is your h, which is in feet, and then your y value would be your function value, a of h, which is in square feet, okay? And it told us that a is continuous and decreases, so we know it's decreasing, okay, as h increases. So in part A, it says use a left Riemann sum with the 3 subintervals indicated by the data in the table to approximate the volume of the tank, okay? So you're going to have one rectangle from 0 to 2, another rectangle from 2 to 5, another rectangle from 5 to 10. So they are not equal in the length of each base. And then when you're using left Riemann sums, remember you're going from the left. So you're going to use your height of 50.3 for your starting rectangle, okay? And then your next one will be a height of 14.4 for your next rectangle. And then your third rectangle will be a height of 6.5, okay? So that'll be your 3 that you'll set up. So for A, when it says use left Riemann sum with 3 subintervals, indicated approximate volume, indicate units of measurement. So this is an approximation, so remember that. Your height will be 50.3, base is 2, plus 14.4, base is 3, plus 6.5, base is 5. And when you calculate that, you get 176.3. And remember, when you are finding that area under the curve, think about your units. You're taking your x unit times your y unit, and that gives you the unit of what you just calculated, okay? So it's 176.3 cubic feet. Then in part B, it asks, does this approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Because it's left bound and the function is decreasing, you can see all that extra space out there, right? That we're going to be counting in our answer. That is not under the curve, so therefore it's an overestimate. So A of H is decreasing as H increases, and a left Riemann sum was used. Okay, part C, it says the area in square feet of the horizontal cross section at height h feet is modeled by the function f given by f of h. Based on this model, find the volume of the tank. Indicate units of measurement. Okay, so you might be asking, what's the difference of what we did for A and B versus C? So for A and B, you used these 4 heights. That's all you knew. You knew the height of the function at time, or at h is 0, or the area when the height was 0. You knew the area when the height was 2. you knew the area when the height was 5, and you knew the area when the height was 10, okay? And then we did our rectangles to estimate the area. Now you're actually going to be given the function that gave us these heights, okay? So that function is f of h. So if we are wanting to find the volume of the tank, all we're doing is an integral. And to complete this, again, you have your calculator, so you can just plug this into your calculator by doing Math 9. You can graph it and calculate the integral from 0 to 10 as well, but this is how you'll get your volume as close to exact as possible. Obviously, our answers will be rounded because you'll have some decimal places, but you'll definitely see that A was an overestimate, okay? So go ahead and plug that in. And when you plug this in, you get that your volume is 101.32534. So this is what you're given, and all of our answers will need to either be truncated to 3 decimal places or rounded, and in this case both would be the same. Again, since we're dealing with volume, make sure we have the correct units, and if you look at the directions, it says indicate units of measurement, so that will be part of your answer, and that will be in cubic feet. Okay, so you can see that that left Riemann sum was an overestimate, 176 compared to the actual rounded to 3 decimal places, 101.325, okay? And then the last part is part D. Water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. Okay, so we know that our volume with respect to h is going to equal the integral from 0 to h of f of x dx. Okay, so off to the side, if you want, you can write what your goal is and what you know. So it tells us that when the height of the water is 5, so when h is 5, the height is increasing at the rate of 0.26 feet per minute. So that means dh dt is 0.26 feet per minute. And we want to find the rate at which the volume of water is changing with respect to time. So we will take the derivative of both sides, and our derivative of volume with respect to time, that's what we're trying to find, is just dv dt. And that is going to equal our derivative with respect to time of this integral. Okay, and how do we find that? That's where our second fundamental theorem of calculus comes in. So remember, we just plug in our variable anywhere we have an x. So that'll become f of h times the derivative of h with respect to time. Okay, so you can write that as h prime. You can also write that as dh dt. Okay, and if you look over here, we know what dh dt is. When h is 5, it's 0.26. Okay, we need to evaluate f of 5 just by going up to that function by plugging it into this right here. So plug in 5 for h. And actually it's approximately 6.5. We don't want to use that 6.5. We want to use all of our decimal places so we're not off. So at 5, our output is 6.51699945. So don't round that yet. So you don't want to use that 6.5 from up above from the table. Multiply that by 0.26. And then that's when you will go ahead and round or truncate to 3 decimal places. And that's where, so when we do this, we get 1.6944187, 3 decimal places right here. Even if we round or truncate, it's the same thing. So our answer will say when h equals 5 feet, the volume of water is changing at a rate of 1.694 cubic feet per minute.